Good students. In the last video, we have discussed how to accept a string in PDA that with the empty stack and with the final state. In this video, we'll discuss how to convert a pushdown automator to context-free grammar and context-free grammar to PDA. As we have already discussed, the formal languages are four types like regular languages, context-free languages, context-sensitive languages, and recursive enumerable languages. So the regular languages are accepted by finite automata or regular grammar or regular expression. So we can convert from every possibility to another one like this. Okay. And we have already discussed these finite automata to regular expression and regular expression to finite automata in the last unit. And even every CFL is recognized by machine called PDA and the grammar called context-free grammar. And every PDA can be converted to grammar and every grammar can be converted to PDA. So this we are going to discuss in this video, conversion of PDA to CFG and CFG to PDA. So that's what we have discussed here, right? See, when you can say that a language is context language if and only if some PDA must accepts it, right? So the language accepted by the PDA, definitely there should be some grammar which is language is same. Okay. So here the leftmost derivations of a string using the stack, one state PDA accepting the empty stack or final state. Okay, we are having some rules to represent it. And when you are converting from a grammar to PDA, you have to check the derivations, leftmost derivations, right, and empty stack, how we have to represent. And when you are converting a PDA to context-free grammar, then you should take care about the operations like push operation, pop operation, and everything. But before going to that, let me tell you one thing. Here, see, as I told you, every context-free grammar can be converted to PDA. And every PDA can be converted to context-free grammar. So while you are converting a PDA to context-free grammar or context-free grammar to PDA, the context-free grammar, the general or direct context-free grammar cannot be converted into PDA. First, this context-free grammar should be represented in either CNF, Chomsky normal form, or GNF, Greeback normal form. So directly we cannot convert. Either you have to represent in CNF or GNF. How we have to represent that? That is our third unit. Normal forms. There we are going to discuss about this conversion of context-free grammar to CNF and GNF. To convert it, first we have to minimize it. So that we'll discuss in the next video, the last video of the second unit, minimization. Then we'll go for the conversion. So first the context-free grammar has to be represented in either CNF or GNF. Then we can convert this into the PDA. So in this video, we'll discuss how this GNF will be converted to PDA. The same way, guys, if you are converting a PDA to CFG, the CFG we are going to get in GNF form only, right? So what is CNF, GNF? Of course, as we have used both GNF for the conversions, let me tell you quickly what a GNF means. So left hand side we should have only one non-terminal, right hand side we are having a terminal followed by any number of non-terminals. The first symbol must be terminal, then it will be having any number of non-terminals. So while you are converting CFG to PDA, also make sure that the starting symbol must be terminal, remaining all are non-terminals. And while you are converting PDA to CFJ, you must ensure that the first symbol is terminal and remaining all are non-terminals. So let me tell you one thing before going to the conversions, guys. So far we didn't get any questions in the OA external exam regarding this equivalence of CFG and PDA. We didn't get it any, but okay, we don't know how it will be happen. I can say that in the last 5 years we got only one time, and that too CFG to PDA only. We didn't get the PDA to CFG even, right? So then okay, we'll go with that first. How to convert a CFG to PDA? First convert into the GNF. This we'll discuss in the unit 3. Okay. So there will be only one state Q on the PDA, right? And that is nothing but the starting symbol. And if we are having a terminal production like this, A tends to alpha, then you have to write Q, the non-terminal and you take epsilon, the same state with the terminal. Right? This is nothing but A tends to alpha, as we are having only one state. But for which input symbol? For any input symbol, you have to substitute A tends to A. That is the meaning of it. Okay. For example, what if you are having A tends to epsilon? Right? Then you can take epsilon. The non-terminal is A here. Okay. So for which terminal A and the states are same. Right. So this is how we are going to represent. Okay. If you have any doubts here, we'll discuss with the example. Don't worry. So there are only two kinds of symbols. Right. If it is anything like non-terminal or anything, like A tends to some symbols, can be a single terminal, single non-terminal, any number of non-terminals, any number of terminals. If you have such, then you can write the non-terminal, whatever the right hand side term we are having here. For any input symbol, the same state, don't change the state. If it is a terminal, like A tends to A or something like that, you can write it. The terminal and the epsilon, we have to pop out. Okay, let me explain this with the example, don't worry. If you are not following this, we'll go with this, how to convert it. See guys, we are having a terminal productions, epsilon production and non-terminal production. How we have to do it first? The rule 1. Here we are having total 5 rules or 5 productions. How to go with that? Same concept here. S tends to this one. S tends to 0 Sx. That's what we have taken. Don't change the state as I told you. And if it is a non-terminal, for any symbol of epsilon. That's the first one. Okay. Then how to write for the 1y? So simple logic, guys. Okay. How to write it? So same state, don't change it. Input symbol is epsilon as it is a non-terminal. Right? For any input symbol, you have to take it. What is a non-terminal you are having here? S tends to. Don't change the state, that is Q only. But which production you have to substitute? 1SY. That's it. Right? They have mentioned R here, but you can write it separately. Then how you have to write for the epsilon? Same concept. Current state is Q. Any input symbol epsilon. The non-terminal is S. Then you have to take Q and epsilon. That's it. See, you can write it individually. They have written it at a time. You can write individual. Okay. This is how they are going to be. Then same way, what we can write for 1. Okay, x1. Same concept you can use here. Okay. Then first you take it Q. For any input symbol, if the non-terminal is X, X tends to 1 and don't change the state. Same way you can write for Y also. Q epsilon Y, then don't change the state of Q for 0. You can write it. But according to the step 2, right, you can write it. For step 1, you have to write for all. But you have to write this step 2 only for what? Terminals. Only for terminals. So if you are having a terminal here, okay, if you are having a terminal, then you can write it Q1 comma 1, nothing but Q comma epsilon path. If you are having like this, same Q0 comma 0, you can write it Q comma epsilon. Like that you can do it. It's very easy to write this. Okay, let me write this. Of course, anyway, I've taken here, but let me go with this. See here, first you have to take S. So Q, for any symbol S, you have to take Q 0 BB. That's it. For this B, how can I write it? Q epsilon B. Then you can take Q comma 0S or Q comma 1S or Q comma 0. As we are having a terminal 0 and one more terminal 1, because the symbols, terminal symbols in the grammar 0 comma 1, then you write one more time like Q comma 0 0, Q comma epsilon. For every terminal you have to write like that. Okay, Q comma 1 comma 1, you have to write Q comma epsilon. That's it. Right. So you can take some examples and you can do that. Then let me go with the conversion of PDA to CFG. Okay, so while you are converting a PDA to CFG, so non-terminals of the G and the starting symbol will be like this: A, Q naught and F. So if you are having a PDA with the 7 tuples. What is the starting state? Q naught. What is the final state? F. Then the starting non-term is denoted with S. So the starting state will be A Q naught comma F. So A Q naught is the starting state, right? So for every WX, Y, Z or QM and S symbol, then you have to write XWX, XYZB. Of course, you are not getting it what I'm trying to tell you here. Let me explain all these things with a simple example, guys. If it is a normal string, you write XWW epsilon. Okay. It's better to go with the example. So we'll come back it, whatever we have discussed here. Let me go with the example so that you'll understand easily. So assume that we have a production like this. These are nothing but the operations, guys. Push operation, pop operation, no push, no pop operation. What we are doing it, that we are discussing, okay? So assume that we have a push operation like this. The D means ID. Current state is Q naught. Initial symbol is 0. Input symbol is 0. Top of the stack is Z naught, pushing it. So first, what is the starting symbol here? Q naught. Then you write S tends to Q naught, Z naught, Q naught. S tends to Q naught, Z naught, Q1. Because we are going to have only two states, that is Q naught and Q1. Right? Because our PDA is having how many states? Two states. So you have to write Q naught, Z naught, Q naught, Q naught, Z naught, Q1. So if you are having three states, you have to write starting state, starting stack symbol, and all the remaining states. Starting state, starting stack symbol, and Q1. If you are having Q2, you have to write one more time. S tends to Q naught, Z naught, Q2. If you are having three states, you have to write like this. Four state, you have to write. So this is common, guys. So remember in that way. The first and foremost symbol is give the starting symbol. S by taking the starting state in everywhere in starting symbol, and how many states you are having in your PDA, you have to write that those many times. That's it. This is about starting symbols in the grammar. And if you have a push operation like this, Q naught 0 Z naught, Q naught X Z naught, right? Okay, same concept here. First, if you are not changing the state, if you are not changing the state for the push operation, then what we can do simply, what is the input symbol we have here? 0, that you have to take it. This is the input symbol. Then you write it X Z naught, right? As the state is not changing, first you write for the X, then you write for the Z. Okay, that's the first one. As we are not changing the state, then in the first step you write the same states for X and Z naught. If you are having X, Y, Z naught, you have to write for X, Y, and Z naught, like Q naught X, Q naught, Q naught Y, Q naught, Q naught, like that. And in the next step, how many states we are having? Two states, then you write, change it. So Q naught X, Q1 and Q1 Z, Q naught. You have to just interchange the states. Different states you have to write. So as states are not changing in the first step, no change, but in the second step must be changed. Let me explain with another one like this. Q naught, Z naught, Q1. Here we are changing the states. The states are changing here, right? So if the states are changing, first you have to write the same state and different state, then different state and same state. If they are not changing, same, same, different, different. If they are changing, same, different, different, same, like you have to write it. Okay, means here Q naught means you have to write Q naught, Q naught, Q naught, Q naught, Q naught, Q1, Q1, Q naught, like that. If the states are changing, what we have to do here, Q naught, Q naught, Q naught, Q1, Q naught, Q1, 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 like you have to do it. Same here again, we are not changing the state, so same states, different states. And we are changing here, so same state, different, different state, same. Right? So for this Q naught, write same, then write different. For the Q1, write different, then same, like that. So this is how we are going to convert. For the terminal, simply you can write it same and different. You can just go with that. So terminals, you don't need to worry about this. Simply you can take it. Only if it is push operation, you will be having the thing. So you can change it. So in the next video, we'll discuss about